Now you'll get to do something new, updating data that's already been stored in the database. Remember when I inserted 2 Julie Lermans? One of me is enough. So I'm going to edit one of those rows and change it to my fancy name, Julia. Julie is my nickname, but Julia is what's on my birth certificate. And for what it's worth, I have been asked so many times how Julie can be a nickname for Julia because it's the same number of letters. But who's counting letters? It's less syllables, so a big time saver, right? Anyway, how to go about fixing that. I'll use EF Core to query the database for the first one of the Julie Lermans. And to be sure I'm getting the right data, I'll filter on the first and last name. Then I do a null check to make sure I did get back some data, and I'll set the first name to Julia and call Save Changes. Notice I didn't use an add or update method here, although it's true there is an update command, which you'll be learning about later. But here, the context is still tracking that author, so when I call Save Changes, it does that quick check of the author values and notices that something has changed. So it sets the state to modified, and then Save Changes knows to build an update command. When we look at what happened in the database, first we see the query to get that row of data. And remember, since I used the link first or default method, that turns into a select top 1 query. Then you can see the second command sent to the database, the update command. And it's saying to set the author name to Julia where the author's ID is 1. And as expected, the update command is parameterized. The ID and the new value of first name were sent in as parameters. With the output clause, the update command will return the affected row count to EF Core. Shortly, you'll see how this works when we send multiple changes, but for now, output 1 is accurate. And in fact, the Save Changes method itself returns an integer representing the number of rows affected by Save Changes. But if we look back at the insert command, it didn't return a row count. Save Changes will count that as 1. I'm not capturing that value, however, so let's move on to another update. Here I'm retrieving and updating a number of authors. People often misspell my last name. They like to put an H in there. So clearly, this method was written by one of those people. It will query for all the authors whose last name is Lerman with the proper spelling. Then it iterates through the results and changes each author's last name to Lehrman, and then calls Save Changes. So again, the context was still tracking these authors when the edit was made, and therefore Save Changes triggers 3 updates to go to the database. If you've been using earlier versions of EF Core but haven't looked at the SQL in a while, this might be surprising. Up through EF Core 6, the SQL Server provider would not batch commands with less than 4 changes. But after further research, the team found that even 2 commands were enough to benefit from batching. So here are 3 update statements coming in as a single command. All of the parameters for those updates are strung together, and each update statement will output the value 1. EF Core will add those up when it determines the return value of the Save Changes method. Also, notice that the calls were wrapped in a transaction. When only updating a single row, there is no need for a transaction, because if that fails, there's nothing else that needs to be rolled back. So it's more efficient in that case. And that blog post about changes to SQL in EF Core 7 mentioned earlier has a lot more detail about this. Now, of course, I'm not happy that the database has mine and my mom's last names misspelled. So I've modified the method to look for all of those Lehrmans and change them back to the correct spelling. But while I'm doing this, I'll show you another interesting and useful feature of how the DB Context Change Tracker is learning about these changes. Remember that the context is not managing the entities directly. And I have said a few times that when you call Save Changes, the context will take one last look at the objects to determine their state and property values. And the way it does that is with a method called detect changes. Detect Changes reads the values of all the entities it's tracking and updates the state details in the tracking objects being managed by the change tracker. Save Changes calls Detect Changes as part of its process. Detect Changes is not an internal method. You can call it yourself if you have a need. And I'm going to do that because I have a need to teach you. I'm also taking advantage of a cool feature that arrived in EF Core 6 called the Debug View. The short view is all we need. There's also a long view, which has a deeper level of details. So after I edit the last names, I'll use the debug view to show you what the context knows about the authors. Remember that the context queried those authors, so it is aware of them. Then I will call Detect Changes explicitly, and after that, once again, we'll see what the context knows about the author entities afterwards. I've added some breakpoints so we can step through this. Here we go. And before Detect Changes is hit, the context says it's tracking 3 objects. Each one is an author type. Their IDs are 1, 3, and 4, and the state of each one is unchanged. So the context is not yet aware of the changes. Now I'll call Detect Changes, and this time the output of Debug View shows that the state of each of our authors is now modified. Save Changes will still call Detect Changes again internally because that's what it does, but the information will be no different. And then when EF Core builds the SQL, everything it needs to know is in the change tracker entity entries. It knows the authors are modified and it's aware of their values. I think it's really helpful to understand that while the DB context is aware of the authors are just plain old objects. They don't have a way of communicating back to the context every time you make some kind of a change. But the context does have its references to each of those entities, and Detect Changes is able to go and read the values and determine their state. This is going to be especially helpful to understand when you're thinking about how EF Core works in web apps where everything is disconnected. The context isn't limited to focusing on one type of change at a time, or even one type at a time. Here's a method where I'm updating an author's last name. I'm changing Josie's last name to Newfoundland, and I'm creating a new author, Dan Appleman, in the same transaction. When I call Save Changes, the context doesn't care that there's one added and one modified object. It will build and execute the needed SQL. And here are the update and the insert coming in as a single command with all of its parameters, and that command is wrapped in a transaction. And just being 100% sure by looking at the database, there's Josie with her new last name, Newfoundland, and Dan Appleman as the last row in the table. Now I'll show you another way to have EF Core perform an update for objects that are not being tracked. Most commonly, this will happen in a disconnected application, like a web app. This time, I'll use EF Core's update command, which explicitly tells the context to set its state to modified. This is very different than making edits on the fly to an object that EF Core is tracking, as you've been seeing so far. To show you this method in a way that makes sense and is more like how a real application works, I've created a set of methods that are similar to the workflow of a web application. First, find that author. This method takes as a parameter an integer representing the ID of an author that you want to find, and then retrieves it using find and returns the resulting author object. A second method, save that author, takes an author object, calls the update method of the author's DB set, passing in that author, and then calls save changes. And the third method coordinates the other two, telling find that author to get the author with ID 3, and if the author's first name is Julie, change it to Julia, and then send the object, which I've just modified, to the save that author method. Notice that I'm explicitly instantiating new pub contexts in the find and save methods. What that means is after the author is retrieved in the find method, its short-lived context that I instantiated gets disposed. So if the context no longer exists, there's nothing tracking that author. So there's nothing tracking that author when I'm back in the coordinator method and it makes a change to the author object. Then when I pass the author object into the save method, we get a brand new context instance that's empty. It's not tracking anything. It doesn't know anything about this author. It doesn't know that the author came from the database, and it doesn't know that I made changes to it. So instead of calling dbSetAdd, which would think the author needs to be inserted into the database, which would create some problems, I'm using the update method. And the update method does two things. First, it causes the context to begin tracking the author, and at the same time, it instructs the context to set the state for that object to modified. Here's the debug view again, showing everything the context is aware of. And we see it knows about the author, including its ID, and because we told it about the state specifically by using the update method, its state is set to modified. When I call save changes, we get an update. If you recall, when I did the earlier updates, while the context was tracking the authors, the update command only had the ID of the author to update and the value of the modified name. And here, I also only made one change to the author, changing the first name. But this update command is updating the last name as well, even though I didn't edit it. Remember that this was a new context that had no idea of the history of what happened to that author in our code. The update command has no way to know what got updated, so it tells the change tracker that every field is modified. And if we go back and look at the long view in the debug view before we called save changes, you can see that the change tracker has marked both the first name and last name properties as modified. It's the only way to be sure that you're getting all of your changes to the database. As you get to more advanced scenarios with EF Core, it's important to understand this, especially in nuanced situations where it could have an adverse side effect on data or performance. But in common scenarios, this is a perfectly good way to handle the update. If there was a context tracking the author at the time that I made the edit, then you wouldn't need to call the update command because, as you've seen, save changes calls detect changes and the context figures it out. But in scenarios such as disconnected applications where you're passing objects around, it will be up to you to somehow inform the context about that state. So your software logic does need to know when something needs to be updated or added or even deleted. The specific methods are the best way to do that.